Looking at this setup, I'm already set up in standard form, but I need my coefficients either on the x's or the y's to be opposites of each other. How can I do that? One option would be to multiply the second fraction by -2. That would give me 2x plus y equals 11. And if I multiply everything by -2, I'd have -2x minus 6y equals -36. So that's one option. Another option would be to multiply the top equation by a -3. We'd have -6x minus 3y equals -33. X plus 3y equals 18. Either way, we're going to be able to eliminate one of the variables. It doesn't matter which variable you eliminate, and it's just whichever you like better, whichever one is easier. Let's stick with the first one. 2x minus 2x, the x's go away. Y minus 6y is -5y. 11 minus 36 is -25. Divide both sides by -5, and we get y equals 5. Alright, now we'll put that into our original equation, one of them. How about 2x plus 5 equals 11? So 2x equals 6, and x equals 3. Again, our solution to this system of equations is a coordinate pair, so we need a 3, 5, an ordered pair. And it wouldn't hurt to double check it. 3 plus 3 times 5, yeah, that is indeed 18. Alright, solve using any method. These look kind of like standard form, but the top one's not quite in standard form. I want my x's in the front and my y's in the back. So let's rewrite this as -x plus y equals 4, and x minus y equals 3. Now I notice my x's have opposite coefficients, so I can add right now and my x's will go away. And when I add my x's, I get nothing, and when I add my y's, I also get nothing, 0. When I add my 4 and my 3, I get a 7. Now, back in the good old days when we were solving equations, if we ended up with something like 0 equals 7, we said that there was no solution. And remember, we called that an inconsistent system. Graphically, that would mean these two lines don't cross, or in other words, they are parallel. Alright, next one. Using any method. Solve using any method. I think that because the top equation doesn't have any x's in it, it would probably be easiest to just substitute the y in. So I think we'll use substitution. 2 plus x plus 3 equals 0. 5 plus x equals 0, so x equals -5. And according to this, y has to be 2. So we have the point -5, 2. Solve using any method. Oh boy. We could use substitution, and I think I will, because when I bring this x and multiply it by 2, I'm going to get rid of that nasty 1/2. So let's do that. 2 times negative 1/2 y plus 6 plus my y equals 12. When I distribute this, 2 times the negative 1/2 y is a negative y. 2 times 6 is 12 plus y equals 12. Combine my y's and I get 12 equals 12. Now, again, back in the good old days when we'd solve a linear equation and we came up with an answer that is true with no variables in it, like 12 equals 12, we would say that the solution was all real numbers. In this case, it's a little different. What this means is that any place for any x, the solutions will overlap. In other words, these two are the same graph. So there's an infinite number of solutions, and again, we call that a dependent system. Solve using any method. This one is not going to be real easy to solve for x or y. So I think what we'll do is use the elimination method. Now, in order to get two of these coefficients to be opposites of each other, multiplying the top by something is not going to be enough. I'm going to need to multiply the top by one thing and the bottom by something else. Now, since I have a positive 3 here and a negative 4, what if I turned these coefficients in front of the y into positive 12 and negative 12? Then they would eliminate each other. The way I'll do that is by multiplying the top equation by 4, giving me 8x plus 12y equals 24. And I'll multiply the bottom equation by 3, giving me 15x minus 12y equals negative 24. And if you came up with a plan to change the 2x and the 5x so that they would eliminate instead of the y's, that would be fine too. So when I add the left side, my 12 y's will go away and I end up with 23x equals 0. Now this looks kind of like that, remember when we had 0 equals 12 and we said there was no solution? The difference though is that this x is still there. So I can still divide both sides by 23 and I get x equals 0 over 23 is just 0. Remember, the zeros can't be in the denominator. They're okay in the numerator. Alright, now if I stick this 0 back into one of my original equations, it's always safest to go with the very original. Don't do any of the modified ones because you may have made a mistake there and we're trying to catch mistakes. So we'll go back to the original equations. 2 times 0 plus 3y equals 6. Well, 2 times 0 means that goes away. So we have 3y equals 6. Divide by 3. And y equals 2. So we have the point 0, 2. We can quickly plug that in to the second equation. 5 times 0 minus 4 times 2. And that is indeed negative 8.